The atom. That's what we have to deal with. The atom. What is the basic structure of it? And then why are we even talking about this in nutrition? That's this video. Atoms and nutrition. You might be wondering, why are we talking about this in a nutrition class? This isn't chemistry. True, but we still have to tie it back in nutrition. So let's look at how we tie that back as we go through this video. But we'll start with, what is an atom? An atom is the building blocks that make up molecules. Atoms are composed of protons, neutrons, and electrons. Protons are positively charged particles. Neutrons are neutral, no charge. Together, the protons and neutrons can make up the nucleus of the atom. The electrons, they're negatively charged. Their negative charges are going to be in this cloud around the nucleus. Now, a lot of diagrams will show them as rings. That's just trying to simplify it. The idea is these neutrons and protons have an attraction that pulls the electrons around them. And those electrons are constantly moving in this cloud, this sphere, or these various shapes around the nucleus. That's where some of the energy lies. So when we start looking at all these structures, we'll say, okay, well, energy, we just talked about that. That's energy of a video. We've dealt with that. But as the electrons potentially get shared between atoms. So if you're looking at the number of electrons around the nucleus, if it's an even number in the most outside valence shell, they're usually stable. They can be themselves. But if it's an odd number, especially if it's only one less than the full max valence, then they're more reactive. They want to bring other electrons in. They want to share. So if you look at the oxygen molecule, a lot of times it's O2. Well, why? Because the electrons want to share, form a bond. By sharing, you then have an even number of electrons. That's better because now they can have our oxygen molecules we can utilize. But energy, okay, come back to this, energy. The energy would be in that bond you just made. So think about the molecules we use in our body, things like glucose. Glucose has a huge number of those bonds that were created. Those bonds contain energy. Those electrons contain energy. Our bodies can utilize that energy by breaking down those bonds and removing those electrons. But it's not always a perfect transformation, because as you're making ATP, adenosine triphosphate, that tri tells you there's 3 phosphates. Each phosphate is bound to the previous. That's stored energy. So when we use ATP, we break one of the phosphates off, releasing the energy. Now, the third phosphate has the highest energy, but you can still break off the second and the first to release energy if you need to. But usually our body's breaking off only that third one and then rebuilding it in a process later on. But unfortunately, that process of capturing that energy from those atoms, those bonds, those electrons, isn't always perfect. Sometimes, as our bodies are trying to make ATP, electrons kind of escape. Now, they're not running off and running somewhere else in the body, but they just leave the process of the chemical reactions. Those electrons sometimes can bind to oxygen, so that O2, creating an unstable molecule. It's referred to as a superoxide. Now, these molecules that have the extra, the odd electron added in, those are known as free radicals. And those free radicals, like that superoxide for oxygen, they're not stable. They can cause damage to our cells. to our DNA, to our RNA. That damage is things your body needs to then repair to become stable and functional. Or if there's enough damage, it might become that cell itself is totally non-functional. So it's important to try to limit, or if they are formed, at least get rid of those free radicals as soon as possible. Because those free radicals, by creating the extra electron on a molecule, for example, one way it can alter is going to be the free radical altering or having an extra electron on a fatty acid. Now, we know fatty acids are part of triglycerides. Triglycerides can help with the membrane permeability. Phospholipids can help with membrane permeability. Both those are lipids that contain fatty acids. So if one all of a sudden has an extra electron, then it's not quite stable. It's not what it wants to be. That fatty acid can impact the next one over. Then that fatty acid can impact the next. And it can create a whole cascade going down the entire lipid bilayer. If you have that occurring, you can alter the membrane permeability, either making it harder or easier for other substances to enter and leave the cell. Here's an example. Let's say that cascade ended up going all the way down to a receptor. And that receptor now has been altered. If that receptor was for glucose or for insulin, now all of a sudden your blood sugar levels are going to be off. And if enough of those receptors are altered in enough cells, it could have enough of an impact on your whole entire body's blood flow as far as glucose levels go. So again, one little change is not a problem, but as they build up and add up, all of a sudden that could be a real issue. Or if any of the channels in that membrane are affected, the movements of various ions could be impacted. Sodium-potassium pump could be impacted, changing that permeability and that energy gradient. So again, these are all as they add up and cause more problems. But you're saying, well, how does this affect nutrition? By what you're eating, you're also eating antioxidants. Antioxidants will help to get rid of and help to clear up problems in a cell like that. So it all comes back to, again, having that balanced diet. So we look at atoms, proton, neutron, electron, energy's there. You form bonds then, that's stored energy. When you make and then break down glucose in your body, you're breaking down those bonds, you're releasing that energy, you're taking those electrons and removing them, releasing more energy, and your body is utilizing the energy from these structures. So we'll tie back into nutrition there. Until the next video.